Hi friends, in this video we are solving a problem on differential equation of first order and first degree. One problem is solve x into cos x into dy by dx plus y into x plus sin x plus cos x is equal to 1. Friends, by the observation you can say this is a first order and first degree differential equation. We have a difference method to solve the first order or first degree differential equation. First method we have variable separable method. Friends, you see, actually in the variable separable method, dx and dy should be in the numerator. Dx and dy should be in the numerator. If taken dx is right side, then you can take y is left side. Means variables dx and x terms are one side, dy and y terms are another side you can take. But if this y is going left side also, right side also, that is 1 by y. So you cannot apply variable separable method. Now, by the observation, you can also say this is in this form. This form means a naught of x into dy by dx plus a1 of x into y is equal to a2 of x. Nothing but a linear differential equation form. Yes or no? Now, we have to write this equation in the standard form. The standard form of linear differential equation is dy by dx plus a1 of x into y by a2 of x is equal to a2 of x by a naught of x. Friends, you see this a1 of x, so working rule I am saying friends, a1 by a2 is we are denoting with p of x into y, and a2 by a naught we are denoting with q of x. Okay, now this is a non-exact differential equation friends, non-exact this is. Okay, in this non-exact differential equation we have to convert to exact. For that, we have to multiply with a suitable factor, that is integrating factor. For the linear differential equation, we have e to the power of integral p of x dx. And the general solution, after getting the integrating factor, the general solution of the first order linear differential equation is y into integrating factor is equal to integral of q into integrating factor dx plus c. If you are simplified this, then you will get the required solution for the first order linear differential. Okay, friends. Now, so if you are compare, this is in this form. Okay. Now, what to do? We have to rewrite. Rewrite means divide with the x cos x. Then we will have dy by dx plus y into x sin x plus cos x divided by x cos x is equal to 1 by x into cos x. Now, this is dy by dx plus, friends, you see denominator is containing a cos x, numerator x cos x plus cos x, x sin x plus cos x, a plus b by c form. So write down a by b plus b by c form. Now you see friends, x getting cancelled, sin x by cos x is nothing but what? Tan x. Now here cos x getting cancelled, the remaining term is 1 by x times of y is there, y I am writing here is equal to this 1 by x cos x is there. 1 by cos you can write as a secant x by. So now this is in the standard form. You see the standard form like this. Yes or no? Now this is a non-exact differential equation. So we have to multiply with a suitable factor. That factor is called integrating factor. So friends, just I am comparing this as comparing with dy by dx plus p of x into y is equal to q of x, where p of x is this one and q of x is this one. Okay. Now integrating factor. Integrating factor is equal to e to the power of integral of p of x. What is the p of x here? You have tan x plus 1 by x into dx. Okay, friends. Now this is e to the power of, what is integral of tan x? We have log of secant x formula. Integral tan x is log of secant x plus 1 by x integration is log x. 1 by x integration is log x. Okay. Now here you observe log a plus log b form. Log a plus log b you can write as log of ab. Okay. Ab means secant x into x. Okay. E and log getting cancelled. Then you will get a integrating factor is equal to e log getting cancelled. Then you will have x into secant x, which is an integrating factor. Now, after getting integrating factor, what you have to do? We need to find out the general solution. The general solution is what you have, y into integrating factor is equal to integral of q into integrating factor dx plus c. Okay, friends. So now the general solution is y into integrating factor is equal to integral of q into integrating factor dx plus c. Y is y. What is the integrating factor here? You have x into secant x. So x I am writing here, x into secant x is equal to integral of q. What is the q you have? Secant x by x. Secant x divided by x into integrating factor is we have x into secant x into dx plus c. Now the denominator x and numerator x getting cancelled. Then you will have integral secant x into secant x is secant square x dx plus c. Friends, what is the integral of secant square x? You have tan x. What is the tan x derivative? Secant square x. So secant square x integration is tan x. This is tan x plus c. Hence, the general solution is x into y into secant x is equal to tan x plus c. Okay, friends? Where c is an arbitrary constant. Hence, in the next video, we are solving this problem. 1 plus x square into dy by dx plus 2xy minus 4x square is equal to 0. This is also linear differential equation of first order. Okay, friends. So, you try to solve this problem. You have to get answer y times of 1 plus x square is equal to 4 by 3 times of x cube plus c, where c being arbitrary constant. Given problem is solve 1 plus x square into dy by dx plus 2xy minus 4x square is equal to 0. Friends, here you observe they are given dy by dx term. So this is by the observation you can say this is the first order and first degree differential equation. Okay. To solve the first order first degree differential equation, we have a first method is variable separable method. Okay. In the variable separable method, we have to write a dy quotients and y quotients are one side and dx and x quotients are another side. Here you have a dy. So if you take dy quotient should be y terms and dx quotient should be x term and dx dy are in the numerator only. But here you have dx in the denominator. So cross multiply. Friends, if we cross multiply, then we will have 2xy minus 4x square into dx. So from this quotient, dx quotient, can you remove the y term? No, it is not possible. So you cannot apply variable separable method. So go for the first order and first degree differential equation form. Okay. Now in the first order first degree standard form we have a general form is a naught of x into dy by dx plus a1 of x into y is equal to a2 of x. This one we have to write in the standard form, that is dy by dx plus p of x into y is equal to q of x. Okay. How you are getting this p of x and q of x means dividing both sides with respect to a naught of x. Okay, divide with a naught of x. Now, this is a non-exact differential equation. Non-exact. So, we have to make it as exact by multiplying with a suitable factor. The factor is said to be integrating factor. We have integrating factor for the linear differential equation is e to the power of integral p of x dx. And the general solution is y into integrating factor is equal to integral of q of x into integrating factor dx plus c. Friends, this is the working rule for the first order and first degree linear differential equation. Okay. Now, we have to convert the given problem 1 into the standard form. For that, you see friends, first I am writing this 4x square should be right side because the right side q of x I want. Now, 1 plus x square times of dy by dx plus 2xy is equal to 4x square, even though it is not in the standard form, because in the standard form dy by dx quotient should be what? 1. But here you have 1 plus x square. So divide with 1 plus x square. Then you will have dy by dx plus 2x by 1 plus x square times of y is equal to 4x square by 1 plus x square. Okay, friends. Now compare this one with dy by dx plus p of x into y is equal to q of x. So what is the p here? P is nothing but 2x by 1 plus x square, which is p. And what is q means? 4x square by 1 plus x square is a q of x. Now we know that the linear differential equation of first order first degree is not exact. So we have to multiply with the integrating factor. That integrating factor formula we have e to the power of integral p of x dx, that is e to the power of integral. What is the p of x here? You have 2x by 1 plus x square dx. Now here you observe, friends, the integrand is 2x by 1 plus x square. So integrand is containing numerator and denominator. Once you verify if numerator and denominator is there, is denominator derivative in the numerator. If the denominator derivative in the numerator, then you can write log of denominator. We are using this formula. So we can write e to the power of 2x by 1 plus x square. If you are applied this formula, then we will have log of f of x. What is the denominator you have? 1 plus x square. We know that e and log getting cancelled, then you will have a 1 plus x square. This is an integrating factor. After getting integrating factor, what we have to do? We have to do the general solution. The general solution is, we know that y into integrating factor is equal to integral of q into integrating factor dx plus c. Now, y into, what is integrating factor here? You have 1 plus x square is equal to integral of q of x. What is the q of x? We have 4x square by 1 plus x square into integrating factor is 1 plus x square, okay, into dx. Now you observe, friends, the denominator we have 1 plus x square and the numerator 1 plus x square is getting cancelled. Then we will have integral of 4x square dx only. What is the integral of 4x square? 4 you can get outside. X square integration is x cube by 3 plus c. Then the general solution is y into 1 plus x square is equal to 4x cube by 3 plus c, where c is an arbitrary constant. Given problem is solve x plus 1 times of dy by dx minus ny is equal to e to the power of x into x plus 1 to the power of n plus 1. By the observation, you can say the given problem is in this form. You see, a naught of x into dy by dx plus a1 of x into y is equal to a2 of x. So this is a linear differential equation of the first order and first degree, but not in the standard form. It's a general form. So we have to convert into standard form by dividing with a naught of x. Then you will have dy by dx plus p of x into y is equal to q of x, where p is nothing but y coefficient. Y coefficient is a1 of x by a naught of x, and q is nothing but a right side part, that is a2 of x by a naught of x. This is called a linear differential equation of the first order and first degree standard form. So friends, we know that this is a non-exact. This is a non-exact. So convert to exact differential equation, we have to multiply with a suitable factor, that is integrating factor. We have a e to the power of integral p of x dx, and the general solution of the given problem is we have y into integrating factor is equal to integral of q of x into integrating factor dx plus c. So this is the procedure to solve this given problem. Now you see, dy in the standard form, dy by dx quotient is what? 1. So divide the given differential equation with the x plus 1. Then we will have dy by dx minus n by x plus 1 times of y is equal to e to the power of x into x plus 1 power n plus 1. Here you have x plus 1 upon, okay, so you can write by n only, n plus 1 by x plus 1 getting cancelled. Now this is, you observe, in the standard form of dy by dx plus p of x into y is equal to q of x form. Yes or no? Where p is equal to y quotient. Y quotient, what you have here? Minus n by x plus 1, and q is the right side part. What is the right side part? We have e to the power of x into x plus 1 to the power n. Okay friends, now how to solve this equation? First we need to find out the integrating factor. Now integrating factor is if, that is e to the power of integral p of x dx. So e to the power of integral, what is the p of x? Here you have minus n, so I am writing a minus n outside, 1 by x plus 1 dx. Friends, you see, here you have a integrand is 1 by x plus 1, nothing but it is containing numerator and denominator. When the integrand is containing numerator and denominator, we have to apply this formula. Verify with this formula, that is integral of f dash of x by f of x dx. That is, observe friends, if the Integrand is containing numerator and denominator. If the denominator derivative in the numerator, you have to write log of denominator. So here you have a denominator x plus 1. What is the x plus 1 derivative? 1. So denominator derivative in the numerator. So what you will write here? E to the power of minus n times of log of denominator. What is the denominator? X plus 1. Friends, this is like in this form. You see, n into log a. N into log a. You can write as a log a to the power of n. So this is e to the power of log of x plus 1 to the power of minus n. Now e and log getting cancelled, then you will have x plus 1 to the power of minus n is an integrating factor. Okay friends, after getting integrating factor, we need to find out the general solution. The general solution we have y into integrating factor is equal to integral of q of x into integrating factor dx plus c. Now substitute integrating factor here, then we will have y into x plus 1 to the power of minus n is equal to integral q of x. What is the q of x we have? E to the power of x into x plus 1. E to the power of x into x plus 1 power n into integrating factor is x plus 1 power minus n into dx plus c. By the observation, you can say x plus 1 power n, x plus 1 power n power minus n getting cancelled, or else n minus 1. Both the bases are equal, so power should be added. N minus n is 0. So x plus 1 power 0 is what? 1 only. Or else you can simply say both will be cancelled. Now you will have integral e power x dx plus c. What is the e to the power of x integration? E power x only plus c. Hence the general solution we have y into x plus 1 to the power minus n is equal to e to the power of x plus c, where c is an arbitrary constant. Given problem is solve dy by dx plus y into cos x is equal to 1 by 2 times of sin 2x. By the observation, we can say the given problem is in the standard form of linear differential equation of first order and first degree. That is dy by dx plus p of x into y is equal to q of x. We know that this is a non-exact differential equation. Okay, non-exact differential equation. The general solution, how to get means working rule we are discussing first. You see friends, if this is a non-exact differential equation, then we have integrating factor is equal to e to the power of integral p of x dx. If you multiply the integrating factor, then the given differential equation will become an exact. And the general solution you will have y into integrating factor is equal to integral of q of x into integrating factor dx plus c. Okay friends, now first the given problem compare with the dy by dx plus p of x into y is equal to q of x, where p is equal to y quotient. What is the y quotient here? You have cos x. Next, q of x is equal to right side part what you have? Sin 2x by 2. Okay friends, now how to solve this equation? This is a non-exact, so we have to find an integrating factor. Integrating factor is we have e to the power of integral p of x dx. So this is equal to e to the power of integral. What is the p of x here? You have cos x dx. So this is e to the power of, what is integration of cos? We have integration of cos is sin x. So sin x only. This is an integrating factor. Finally, we have integrating factor is e to the power of sin x. Okay. Next, we have to find the general solution. The general solution we have y into integrating factor is equal to integral q of x into integrating factor dx plus c. Now, to get the general solution, we have to substitute integrating factor on both sides. Then y into integrating factor is we have e to the power of sin x is equal to integral q of x. What is the q of x? We have sin 2x by 2. Sin 2x by 2. And integrating factor is what you have? E to the power of sin x dx plus c. Friends, here you observe we have a product of two terms. One is the sine function, another one is exponential function. So you cannot apply integral uv dx rule. Uv rule you cannot apply directly. So what we have to do means we have to go for the substitution. What we have to substitute means here e power what we have? Sin x. So let sin x is equal to t. If you consider sin x is equal to t, then we have to differentiate on both sides. Then we will have sin x dx. Sin x derivative is cos x into dx is equal to dt. Okay, friends. Now we have to substitute this value here. But here you have a sin 2x. Sin 2x, how you can write actually? Sin 2x, I want in terms of sin and cosine. We have a sin 2x is 2 sin x cos x. Sin x cos x. So first I am writing like that. 1 by 2 I am writing outside. Then integral sin 2x is I can write as 2 into sin x into cos x into e to the power of sin x dx plus c. Now I am substituting sin x is equal to t. Okay. Now here outside we have a denominator 2 and inside you have a numerator 2. So both are getting cancelled. Then you will have integral of sin x. I am substituting what? T. So first in the e power I am substituting e to the power of t. Here you have a sin x. So substitute t. Next cos x dx is left. Cos x dx is what we have? Plus c. Now you observe, friends. We are integrand is here we have e power t into t. So we can integrate this one. How it is? How you can integrate means here you have a product of two terms. Generally, whenever you have a product of two terms, you have to apply integral uv rule. Okay, but here one is exponential function and the one is a polynomial function. Can we apply uv rule means? Yes, you can apply. Here you cannot apply because this is exponential function. This is a trigonometric function. When you have both exponential and trigonometric, you cannot apply directly uv rule. So when you can apply means if that first term, any one of the term is containing algebraic term, you can apply directly. Now integral uv rule I am applying. Here you see we have a u v1 minus u dash v2 plus u double dash v3. From the integral by parts I am saying this formula. Okay. Now integral e to the power of t into t. First one which derivative is decreasing? Polynomial derivative will be decreasing. So this one you consider as u and this one you consider as a v. Now you see, friends, u into u means t into v1. V1 means e power t integration is again e power t minus u dash. U dash means t derivative 1. V2. V2 means this is, friends, u. This is v1. This is u dash. Now v2 is nothing but e power t derivative again what? E power t only. This is v2 plus u double dash. U double dash is what you have? 0. So no need to write. So if you are simplify this, then e to the power of t into t minus e to the power of t. Okay. Friends, from this you can take e power t is a common. So if I take an e power t is common, then we will have t minus 1. Now the general solution should be in terms of what? Y and x only. But here you have a t. So replace t by what? Sin x. You consider t is equal to sin x only. Yes or no? You see. So this one you will have e to the power of sin x into sin x minus 1. Actually plus c also I have to write. Then plus c. Hence the general solution is y into e to the power of sin x is equal to e power sin x into sin x minus 1 plus c. Up to this you can stop. Otherwise what you can do means divide entire equation with e to the power of sin x. Then you will have y is equal to e power sin x getting cancelled. Then we are getting sin x minus 1 plus c into e to the power of minus sin x. Friends, if you are written this one or this one, both will be correct only. Okay, friends. So is it clear how to solve the linear differential equation of first order and first degree? Thank you for watching this video.